So, dear students, up till now we have had a very detailed discussion on the k-means clustering algorithm. We had a look on the algorithm, its flowchart, and the basic steps, and then we have seen two different numerical examples to understand the basic concept of k-means algorithm. And then we also discussed two important points. One is about the stopping criteria, and the other is for the optimal value of k, which is the total number of clusters, right? So these are basically more or less the main important points of a k-means clustering. In order to further explain, or in order to have a much better understanding of k-means algorithm, we will now look into our third example, which can be very helpful in order to further have a fully understanding of k-means clustering algorithm. So in this example, we will have a step-by-step approach, and we will use the same algorithm, which is the algorithm for k-means clustering, and we will be basically clustering 10 data points here, right? So we have 10 data points that we want to divide into two clusters, right? So I have selected the value of 2 because we want to cluster these 10 data points into two clusters. So let's have a review or a quick look again on our basic algorithm. So in iteration number 1, so now we know that we are repeating these steps in iterations. So in iteration number 1, we are basically randomly assigning 2 points in the data set as centers. So we can have, for this example, we can have 1 1 and minus 3 2 as our cluster centers, right? So we can have 1 1 as our first cluster center, and minus 3 2 as our second cluster center. These points will act as the centers of the two clusters that we want to create. So these 2 points will be acting as the centroid or the cluster centers, right? So this was step number 1, in which we have our cluster centers. In step number 2, we measure the distance of each of the points from the two centers picked in step 1 and assign it to the cluster of whichever center they are the closest to, that is the center with highest similarity. So the center with the highest similarity will have that specific data point, and the other one will have the other data point. Now I will show you an image, and you will see that in that image each point will be seen turning yellow or red based on which center it is closest to, right? So basically step 1 computes the cluster centers, and step 2 divides all the points in the data into these two clusters, right? So step 1 is for the computation of the cluster center, and step 2 is basically divides all the points in the data into two clusters. Splitting the data into these k is equals to 2 clusters is done on the basis of distance, which is Euclidean distance, and we are calculating this distance from the cluster center to the data point. If point A is closer to C1 our centroid 1, then center C2, then the point A will be assigned to cluster number 1, right? So now let's have a look at the figure, which will be which you can visualize to with different colors, and you will see that we are basically using the Euclidean distances in order to assign different data samples to different classes. So in this figure you will note that the color of each point is being changed after calculating the distance with the cluster centers. So we have seen that for our first iteration we have these two center points. So our first center point or first cluster is this one 1 1, and our second cluster center is minus 3 2. So if I will start this algorithm in iteration 1, it will calculate the distance of this to this and this. Similarly, both of these cluster centers will be having distance being computed for each data sample. So this data sample, these two distances, this data sample, these two distances, and this data sample, these two distances. And on the basis of the distance, you will see that it is calculating this d, and the minimum distance on the basis of the minimum distance, it is basically assigning the colors. So this is the cluster number 1 and this green one is the cluster number 2. So in this way, by calculating the distances of each data point, we are updating the clusters. And once we have all these distances calculated, like you are seeing here, that each distance here it is 2.8, similarly here it is 5.3, here it is 7.2, that's why it is being turned yellow, and this is basically turned yellow because the minimum distance was with this cluster. So this is a very good example through which we can visualize how distances are being calculated and how each data point is being assigned to different cluster centers. And once we have these cluster centers, then we need to update our centroid. So now our updated centroid is this black one, right? So this is the new cluster center because the values are assigned to cluster number 1. So that's why we have new cluster centers, right? So now once we have all these distances measures, right, we can write them in a tabular format, and in which we are basically calculating the distance of each data point with the cluster center. So for cluster center 1 1, it will have a distance of 0 with itself, but with a distance of 4.1 with the second cluster center. And then this point 1 3, which is our second data point, this one, it has a distance of 2 with 1 1 and has a distance of 4.12 with the cluster center minus a2. So we have all these distances, which I have also showed you in the previous animation, in a tabular format. And then once we have all these data points, we need to calculate, or we need to update our cluster center, and with that cluster center or centroid can be updated by taking the mean or average. So once you compute the mean and average for both the cluster center and for both x and y values, you will see that you will have these values as 1.71, 0.57, minus 3 and 1.33, and these new or updated cluster centers will be used for the next iterations. So you will see that in iteration number 2, we are using the new cluster centers and we are calculating the distance of each data point with the new cluster centers, and we are basically forming the same table having the distances for each data point and the cluster center. And when we will do it for all the iterations until we reach to a convergence or to a stopping criteria, we can see that we have basically formed two different clusters. One is this cluster and one is this cluster, and our data set or data points have been clustered successfully into two different groups based on their attributes and properties. Since the cluster assignments have stabilized, that is, the cluster assignments don't change anymore, we can stop the iterations and report this as the final cluster. So for this specific example, we are choosing our stopping criteria on the basis of stabilization, right? So we have seen that the cluster assignments are not being changed anymore, so that's why we can stop our algorithm. It is important to note that the final clusters depend on the initial centers. Try starting with different centers and see if you land with different clusters than above. So the total number of clusters, or the cluster which we have formed here in this example, relies on the initialization of the centers. So if you select different centers, then maybe you will form some different clusters. So this is something which you can try with yourself and try to execute the same example with different initial centers and see that how much different results or different clusters you can form by using the same data points.